Hello, welcome to Engineers Mindset. Okay, so in the previous video, we've talked about how to differentiate inverse trigonometric functions. Alright, so in this video, we are going to be applying everything we learned there towards solving problems. Now, let's say I have y to be equal to the tan inverse of 1 minus x all over 1 plus x. Let's say I have this and I'm asked to find the y, the x. Okay, and I'm asked to find the y all over the x. Okay, so from y equals tan inverse of 1 minus x all over 1 minus x 1 plus x. Okay, this is what I will do. I will simply say let u, okay, let a be equal to 1 minus x all over 1 plus x. I'll simply say let a be equal to what? The variable in front of the trig function, which is simply 1 minus x all over 1 plus x. So if this happens, it now actually implies that y now is actually what? Tan inverse of a, because I'm calling the whole of this function as what? A. So y is actually tan inverse of what? A. So from here, like I've said, y is now a function of a. Meanwhile, a is a function of x. And if you have been following up my differentiation series, I said whenever you have function of a function, then the only rule which we are going to apply to differentiate is actually what? The chain rule. And what is the chain rule? From here now, I have that y is a function of what? A. Y depends on a. So y is a function of a. This actually means that I can only differentiate or find the y all over what? The a. That's what it means. Since y is a function of a, it means I can only differentiate y with respect to a, and that simply gives me the y, the a. Also from here, a depends on the values of x. So which means a is also what? A function of what? X. And if a is a function of x, it means I can differentiate a only with respect to x. So this will simply give me what? The a all over the x. So it means I can only find the a all over the x. And of course, the y, the question says we should find the y, the x. The y, the x is actually what? Coming from multiplying what? These two derivatives. So I will simply obtain dy all over the x is simply what? I have here dy the a, okay, all over the a, multiplying here the a all over the x, and this is simply called the chain rule. So from here, the a cancels the a, I will simply have the y, the x. So all I need to do now is simply what? Find the y, the a, and find the a, the x. Multiply them together, it will give me the y, the x. All right, so if we've established this, now let's find the y, the a. From y equals tan inverse of a. Okay, we've already proven this in the previous video. We can simply find the y all over the a, and this will simply give us what? 1 all over 1 plus a squared. Okay, so we can have this when we differentiate the tan inverse of a. It will give us this expression. We've done that in the previous video. Please look up the previous videos for inverse trig function differentiation to properly understand how we got this derivative. Okay, but we recall that a is equal to, not forgetting, 1 minus x all over 1 plus x. So in place of a squared, it means now that the y all over the a is actually equal to 1 all over 1 plus. In place of a squared here, we'll simply put in the value of a becomes 1 minus x all over 1 plus x all squared. So we have this. Okay, so if I have the y, the a to be this, let's now try to expand this function. I'm simply going to have the y all over the a equals 1 all over 1. Now this is same thing as saying 1 plus 1 minus x all squared all over 1 plus x all squared. Okay, so we can also rewrite this equation as simply this. Okay, so we have here the y over the a is now equal to 1 all over. So we simply take LCM here. Of course, this 1 is same as saying 1 divides by 1. It still gives you 1, still the same thing. So simply take the LCM between these two. It remains 1 plus x all squared. Okay, so we have this. Now 1 plus x all squared divides by 1 gives us 1 plus x all squared. So simply multiply 1 to it. Or from here, after obtaining the LCM, all you need to do is simply cross multiply. Let this term multiply 1 and let this term multiply the whole of this. So we'll simply have the whole of this 1 plus x squared, 1 plus x all squared multiplying 1. That simply gives us 1 plus x all squared multiplied by 1 still remains 1 plus x squared. Okay, plus same thing here. Use 1 to multiply the whole of this variable. It becomes 1 times 1 minus x all squared. So I'll simply have 1 minus x all squared. Okay, and of course we can simply have now the y all over the a to now be equal to, so since we have this variable dividing by this variable, we can now employ our board mass. This means 1 here is actually dividing 1 and this is dividing this, so we simply have 1 all over 1 multiply. So we change this division sign to multiplication sign. Okay, we'll change division sign to multiplication sign. So we simply have 1 plus x all squared all over 1 plus x all squared plus 1 minus x all squared. So I have this. So therefore, I can obtain the y, the a, to now be equal to, this is simply 1 plus x all squared all over, of course, this multiplies by 1 gives us 1 plus x squared, and the whole of this multiplies by 1 simply gives us 1 plus x all squared minus, okay, plus 1 minus x all squared. So we can keep this aside for the y, the a. Okay, the second part of that rule simply says find the a, the x, and we know the value of a. We said a is simply 1 minus x all over 1 plus x, so we can differentiate a with respect to x from here. Let's try it and see. From a equals 1 minus x all over 1 plus x. Okay, so of course we are going to employ the quotient rule to differentiate this function. Please look up the quotient rule differentiation series on my channel for proper understanding. So we are going to employ that method here to differentiate this function. Okay, so differentiating a with respect to x from quotient rule, keep the bottom. The bottom is simply the denominator. So we simply have 1 plus x, keep the denominator, differentiate the numerator with respect to x. So if I differentiate 1 here, 1 is a constant. The derivative of every constant is 0, so it's off. Minus, if I differentiate x here, x will simply give me what? 1. So I'll simply have that to be minus 1. Okay, minus, now you keep the top, which is simply 1 minus x. Now you differentiate the bottom, same thing here. If I differentiate the bottom, which is the denominator, with respect to x, if I differentiate 1, 1 is a constant and it's off 0. Now I have plus. If I differentiate x, x is 1. So I'll simply have 1, okay, all over the bottom squared, okay, which is simply 1 plus x all squared. So I have this, okay. So the a all over the x is now equal to, so if I will expand this bracket now with minus sign, 1 times minus 1 simply gives me minus 1. X times minus 1 simply gives me minus x. Same thing here. I will expand this bracket with this negative sign. Of course, minus times 1 is minus 1 times 1 still gives us minus 1. So I have minus 1. Okay. Minus times minus x here is simply what? Plus x, of course. X times 1 still gives us x. Okay. All over, I have here 1 plus x all squared. So I will simply have the a all over the x to now be equal to, so from here I have minus x plus x, that's off. Minus plus is 0, minus x plus x is 0, so it's off. Minus 1 minus 1 here gives me minus 2. So this is actually minus 2 all over 1 plus x all squared. So this gives me the derivative of a with respect to x. So I've obtained the y, the a, I've obtained the a, the x. All I need to do is simply plug into this equation and I'll obtain the y, the x. All right, let's try it and see. All right, so from here now, the y all over the x is now equal to, so we have the y, the a, and the y, the a simply gave us the whole of this, which is simply 1 plus x all squared all over, okay, 1 plus x squared all squared plus 1 minus x all squared multiplies by the a dx, and the a dx simply gave us this minus 2 all over 1 plus x all squared. So from here now, it is clear 1 plus x squared can cancel 1 plus x squared. So this simply means that the y dx is actually what? So I'm left with minus 2 here, becomes minus 2 all over 1 plus x all squared plus 1 minus x all squared. Okay, so you may wish to want to leave your answer like this, or you may wish to actually expand the brackets and you get a value. All right, but let's expand the bracket and see what we're going to obtain. Okay, so the y dx is now minus 2 all over, if we expand 1 plus x squared, of course we'll have 1 plus 2x plus x squared. All right, so plus if we expand 1 minus x squared, we have 1 minus 2x plus x all squared. Okay, so we'll simply have this. Okay, so 2x minus 2x is off. So I have here 1 plus 1 gives me 2. X squared plus x squared gives me 2x squared. So this actually implies that the y dx is actually minus 2 all over, okay, 1 plus 1 is 2. 2x minus 2x is off. X squared plus x squared gives me plus 2x squared. And of course, if you look closely, you can see that 2 is common between these variables. So we can actually factorize 2, okay? So if we factorize 2 here, we simply have the y all over the x equals, we have minus 2 here all over 2 is common between here, between 2 and then 2x squared. So we simply pick out 2 into 1 plus x squared. Okay, so we have this. So from here, 2 goes here is 1, 2 goes here is 1. It's off. This actually implies that the y dx is actually minus 1 all over 1 plus x squared. And that becomes the answer to that derivative. All right, guys. I hope you enjoyed this wonderful video on differentiation of inverse three functions. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you're new to the channel, don't forget to hit the subscribe button for more subscribers. I will see you in the next video. Thanks and cheers.